Hello learners, welcome to the course Statistics for Economics. In this module, we shall solve some practical problems that covers the concepts discussed in this course. Following data are related to the weekly wages in 1000 rupees of workers in a factory: 100, 75, 79, 80, 110, 93, 109, 84, 95, 77, 100, 89, 84, 81, 106, 96, 94, 83, 95, 78, 101, 99, 83, 89, 102, 97, 93, 82, 97, 80, 102, 96, 87, 99, 107, 99, 97, 80, 98, 93, 106, 94, 88, 104, 103, 100, 98, 84, 100, 96, 86, 93, 89, 100, 101, 102, 99, 86, 105, 97, 82, 92, 75, 103, 101, 103, 100, 88, 106, 98, 87, 90, 73, 104, 101, 107, 97, 91, 103, 98, 109, 86, 78, 107, 86, 107, 88, 93, 85, 98, 104, 78, 79, 110, 94, 108, 86, 94, 84, 87. Using Stark's rule, convert the above data into frequency distribution by exclusive method. Find midpoint of the distribution. Find less than cumulative frequency of the distribution. Compute more than cumulative frequency of the distribution. Compute frequency density. Compute relative frequency. Compute percentage frequency. Now, let us solve this problem. According to Stark's rule, in order to determine the number of classes, we use the formula k is equal to 1 plus 3.322 log n to base 10, which implies k is equal to 1 plus 3.322 log 100 to base 10. Now, using the log table, the value of log 100 to base 10 is 2. Therefore, k is equal to 1 plus 3.322 into 2, which implies k is equal to 1 plus 6.644, which implies k is equal to 7.644, which is approximately 8. Hence, the number of classes is equal to 8. Now, the width of the class is decided using the formula width, which is denoted by I, is equal to maximum value minus minimum value divided by number of classes. That is, from the data we observe that the maximum value is 110 and the minimum value is 75. Therefore, width I is equal to 110 minus 75 divided by 7.644, which is equal to 35 divided by 7.644, which is equal to 4.5787, which can be approximated to 5. Therefore, the width of each class is equal to 5. As the minimum weekly wages is observed to be 75, using the Stark's rule, the width of the class is 5. Hence, we consider the class intervals as 75 to 80, 80 to 85, 85 to 90, 90 to 95, 95 to 100, 100 to 105, 105 to 110 and 110 to 115. Now, looking into the observations, we group them using the tally marks in the second column. The first observation in the data is 100. Hence, put a tally mark corresponding to the class interval 100 to 105. The second observation in the data is 75. Hence, put a tally mark corresponding to the class interval 75 to 80. The third observation in the data is 79, which is also marked corresponding to the class interval 75 to 80. Similarly, proceed with tallying the remaining observations. Once all the observations are tally marked, count the number of tally marks and enter them in the third column called as frequency. Hence, for this data, the frequencies of the class 75 to 80 is 9, 80 to 85 is 12, 85 to 90 is 15, 90 to 95 is 11, 95 to 100 is 20, 100 to 105 is 20, 105 to 110 is 11 and 110 to 115 is 2. Adding all the frequency value is total is 100, which is denoted by capital N. Next, we need to compute the midpoint of the class intervals. The midpoint is given by the formula lower limit of the class plus upper limit of the class divided by 2. For the first class, the lower limit is 75 and upper limit is 80. Hence, the midpoint is 75 plus 80 divided by 2, which is equal to 77.5. For the second class, the lower limit is 80 and the upper limit is 85. Hence, the midpoint is 80 plus 85 divided by 2, which is equal to 82.5. Similarly, proceeding for the other class intervals, the midpoint obtained are 87.5, 92.5, 97.5, 102.5, 107.5, 112.5, which are entered as in column 4 of the table. Now, we shall compute the less than cumulative frequency values. For the first class, the less than cumulative frequency is 9. For the second class, the less than cumulative frequency is 9 plus 12, which is equal to 21. For the third class, the less than cumulative frequency is 21 plus 15, which is equal to 36. Then 36 plus 11 is 47. Then 47 plus 20 is 67. Then 67 plus 20 is 87. Then 87 plus 11 is 98. Finally, 98 plus 2 is equal to 100. The less than cumulative frequency is as entered in column 5 of the table. Next, we compute the more than cumulative frequency values. That is, as all the values in the data is more than 75, we enter the number of observations 100 in the class 75 to 80. Then, for the class 80 to 85, the more than cumulative frequency is 100 minus 9, which is 91. Then for the class 85 to 90, the more than cumulative frequency is 91 minus 15, which is equal to 79. Similarly, proceeding, the more than cumulative frequency values are 64, 53, 33, 13 and 2. The more than cumulative frequency is as in column 6 of the table. Now, in order to compute the frequency density, the formula used is frequency of the class divided by width of the class. Therefore, for the first class 75 to 80, the frequency density is 9 divided by width 5, which is equal to 1.8. For the class 80 to 85, the frequency density is 12 divided by 5, which is equal to 2.4. Then for the class 85 to 90, it is 15 divided by 5, that is 3. For the class 90 to 95, it is 11 divided by 5, which is 2.2. Proceeding similarly, we have the frequency density of other classes as 4, 4, 2.2, 0.4, which is as shown in column 7 of the table. Next, we need to compute the relative frequency, which is given by frequency of the class divided by total frequency. Hence, the relative frequency values of the considered class intervals are 0.09, 0.12, 0.15, 0.11, 0.2, 0.2, 0.11, 0.02, which is as shown in column 8 of the table. In order to compute the percentage frequency, we need to multiply the relative frequency by 100. Hence, the resulting percentage frequencies are 9, 12, 15, 11, 20, 20, 11, 2 for their respective classes, which is as shown in column 9. The following is the frequency distribution of the number of telephone calls received in 245 successive 1-minute intervals at an exchange. The number of calls are 0, 1, 2, 3, 4, 5, 6, 7 and their corresponding frequencies are 14, 21, 25, 43, 51, 40, 39, 12. Obtain the mean number of calls, obtain the median number of calls, obtain the mode number of calls, show that the sum of the deviations of the given set of observations from their arithmetic mean is 0, verify the property sum of squares of deviation of a set of values is minimum when it is taken from mean. Let X denote the number of telephone calls received in 1-minute interval at an exchange. We shall tabulate the data with entries of X as 0, 1, 2, 3, 4, 5, 6, 7 in the first column and frequencies as 14, 21, 25, 43, 51, 40, 39, 12 in the second column, and the total frequency is n is equal to 245. As it is a discrete frequency distribution, the mean is computed using the formula x bar is equal to summation fx divided by n. So, in the third column, we shall compute fx. The values of fx are 0, 21, 50, 129, 204, 200, 234, 84. By adding all the fx values, we get the sum as 922. Now, divide this sum by n, that is 245. The value is 3.7633. Hence, the mean of the data is 3.7633. That is, the mean number of calls received in 1 minute interval at an exchange is 3.7633. In order to compute the median, we have to check if the observations are ordered. From the table, we see that the x observations are in ascending order. Now, we shall find the less than cumulative frequency as in the column 4. The less than cumulative frequency values are 14, 35, 60, 103, 154, 194, 233, 245. Next, in order to find the median value, compute n by 2th observation, that is 245 divided by 2th item, which is equal to 122.5th item. The less than cumulative frequency greater than 122.5 is 154 and the corresponding x value is 4. Hence, the median of the data is 4. Mode is defined as the variable value corresponding to the maximum frequency in the table. We observe that the maximum frequency is 51 and the corresponding variable value is 4. Hence, mode of the distribution is 4. In order to prove that sum of the deviations of the given set of observations from their arithmetic mean is 0, first we shall consider the deviation of the observations from its mean. The values are minus 3.7632, minus 2.7632, minus 1.7633, minus 0.7633, 0.23673, 1.2367, 2.2367, 3.2367, which are entered in column 4. Next, we shall compute f into x minus x bar. The values are minus 53, minus 58, minus 44, minus 33, 12, 49, 87, 39. Adding these values, we get their sum as 0. Hence, this property is verified. In order to verify property, sum of squares of deviation of a set of values is minimum when it is taken from mean, we shall consider the deviation from mean, median, mode and some arbitrary value and compare them for verification. First, we shall consider the sum of squares of deviation of a set of values from mean. As a first step, compute the deviation of the observations from its mean, and the values are minus 3.7632, minus 2.7632, minus 1.7633, minus 0.7633, 0.23673, 1.2367, 2.2367, 3.2367. which are entered in third column. Now, square these observations. The values are 14.1622, 7.6356, 3.1091, 0.5826, 0.05604, 1.52951, 5.0030, 10.4764, which are entered in column 4. Then multiply the values of column 4 with the frequency values in column 2. The values are 198.27, 160.35, 77.73, 25.05, 2.86, 61.18, 195.12, 125.72, which are as entered in column 5. Now, the sum of f into x minus x bar square is 846.2694. Next, we shall consider the sum of squares of deviation of a set of values from median. As a first step, compute the deviations of the observations from its median, and the values are -4, -3, -2, -1, 0, 1, 2, 3, which are entered in third column. Now, square these observations. The values are 16, 9, 4, 1, 0, 1, 4, 9, which are entered in column 4. Then, multiply the values of column 4 with the frequency values in column 2. The values are 224, 189, 100, 43, 0, 40, 156, 108, which are as entered in column 5. Now, the sum of f into x minus median square is 860. Next, we shall consider the sum of squares of deviation of a set of values from mode. As a first step, compute the deviations of the observations from its mode, and the values are -4, -3, -2, -1, 0, 1, 2, 3, which are entered in third column. Now, square these observations. The values are 16, 9, 4, 1, 0, 1, 4, 9, which are entered in column 4. Then, multiply the values of column 4 with the frequency values in column 3. The values are 224, 189, 100, 43, 0, 40, 156, 108. Which are as entered in column 5. Now, the sum of f into x minus mode square is 860. Now, we shall consider an arbitrary value a is equal to 3. As a first step, compute the deviations of the observations from an arbitrary value, and the values are -3, -2, -1, 0, 1, 2, 3, 4, which are entered in third column. Now square these observations. The values are 9, 4, 1, 0, 1, 4, 9, 16, which are entered in column 4. Then multiply the values of column 4 with the frequency values in column 2. The values are 126, 84, 25, 0, 51, 160, 351, 192, which are as entered in column 5. Now, the sum of f into x minus arbitrary value square is 989. Comparing all the 4 values, we observe that summation f into x minus x bar whole square is equal to 846.2694 is minimum. Hence, we can say that sum of squares of deviations of a set of values is minimum when it is taken from mean. A certain number of salesmen were appointed in different territories, and the following data were compiled from their sales reports. The sales are recorded in thousands in the intervals 4 to 8, 8 to 12, 12 to 16, 16 to 20, 20 to 24, 24 to 28, 28 to 32, 32 to 36, 36 to 40. The number of salesmen are 11, 13, 16, 14, 10, 9, 17, 6, 4 respectively. Obtain the mean sales. Obtain the median number of sales. Obtain the mode number of sales. Show that the sum of the deviations of the given set of observations from their arithmetic mean is 0. Verify the property sum of squares of deviation of a set of values is minimum when it is taken from mean. Let us first tabulate the data considering first column sales in 1000 as class intervals and the number of salesmen as frequencies in the second column. The sum of the frequencies is 100. Now, for each class interval, compute the midpoint and denote it as x in the third column. The midpoint values are 6, 10, 14, 18, 22, 26, 30, 34, 38. The mean is computed using the formula x bar is equal to summation fx divided by n. So, in the third column, we shall compute fx. The values of fx are 66, 130, 224, 252, 220, 234, 510, 204, 152. By adding all the fx values, we get the sum as 1992. Now, divide this sum by n, that is 100. The value is 19.92. Hence, the mean of the data is 19.92. That is, the mean sales is 19.92. In order to compute the median, we have to check if the observations are ordered. From the table, we see that the x observations are in ascending order. Now, we shall find the less than cumulative frequency as in the column 4. The less than cumulative frequency values are 11, 24, 40, 54, 64, 73, 90, 96, 100. Next, in order to find the median value, compute n by 2th observation, that is 100 divided by 2th item, which is equal to 50th item. The less than cumulative frequency greater than 50 is 54 and the corresponding class is 16 to 20, which is called as median class. The interpolation formula used to compute median is median is equal to L plus H by F into N by 2 minus C, where L is equal to lower limit of the median class, which is equal to 16, H is equal to the width of the median class, which is equal to 4, F is the frequency of the median class, which is equal to 14, N is the total frequency, which is equal to 100, C is the cumulative frequency preceding the median class, which is equal to 40. Therefore, median is equal to 16 plus 4 by 14 into 100 by 2 minus 40, which is equal to 16 plus 4 by 14 into 50 minus 40, which is equal to 16 plus 4 by 14 into 10, which is equal to 16 plus 40 by 14, which is equal to 16 plus 2.8571, which is equal to 18.8571. Therefore, the median sales is 18.85. In order to compute the mode, we have to identify the maximum frequency in the frequency distribution. From the table, we observe that the maximum frequency is 17 and it is observed in the class 28 to 32. Hence, the modal class is 28 to 32. The interpolation formula used to calculate mode is mode is equal to L plus H into F1 minus F0 divided by 2F1 minus F0 minus F2, where L is the lower limit of the modal class, which is equal to 28, H is the width of the modal class, which is equal to 4, F1 is the frequency of the modal class, which is equal to 17, F0 is the frequency of the class preceding the modal class, which is equal to 9, F2 is the frequency of the class succeeding the modal class, which is equal to 6. Therefore, mode is equal to 28 plus 4 into 17 minus 9 divided by 2 into 17 minus 9 minus 6, which is equal to 28 plus 4 into 8 divided by 34 minus 9 minus 6, which is equal to 28 plus 32 divided by 19, which is equal to 28 plus 1.842, which is equal to 29.6842. Therefore, mode sales is 29.6842. In order to prove that sum of the deviations of the given set of observations from their arithmetic mean is 0, first we shall consider the deviations of the observations from its mean. The values are minus 13.92, minus 9.92, minus 5.92, minus 1.92, 2.08, 6.08, 10.08, 14.08, 18.08, which are entered in column 4. Next, we shall compute f into x minus x bar. The values are minus 153.12, minus 128.96, minus 94.72, minus 26.88, 20.8, 54.72, 171.36, 84.48, 72.32. Adding these values, we get their sum as 0. Hence, the property is verified. In order to verify property, sum of squares of deviations of a set of values is minimum when it is taken from mean, we shall consider the deviations from mean, median, mode and some arbitrary value and compare them for verification. First, we shall consider the sum of squares of deviation of a set of values from mean. As a first step, compute the deviations of the observations from its mean, and the values are minus 13.92, minus 9.92, minus 5.92, minus 1.92, 2.08, 6.08, 10.08, 14.08, 18.08, which are entered in the column 4. Now, square these observations. The values are 193.7664, 98.4064, 35.0464, 3.6864, 4.3264, 36.9664, 101.6064, 198.2464, 326.8864, which are entered in column 5. Then, multiply the values of column 5 with the frequency values in column 3. The values are 2131.43, 1279.28, 560.7424, 51.6096, 43.264, 332.6975, 1727.309, 1189.478, 1307.546, which are as entered in column 6. Now, the sum of f into x minus x bar square is 8623.36. Next, we shall consider the sum of squares of deviation of a set of values from median. As a first step, compute the deviations of the observations from its mode, and the values are minus 2.642, minus 19.6842, minus 15.6842, minus 11.6842, minus 7.6842, minus 3.6842, 0.3158, 0.43158, 8.3158, which are entered in the fourth column. Now, square these observations. The values are 560.9413, 387.4677, 245.9941, 136.5205, 59.04693, 13.5833, 0.09973, 18.6262, 69.1525, which are entered in column 5. Then, multiply the values of column 5 with the frequency values in column 3. The values are 6170.355, 5037.08, 3935.906, 1911.287, 590.4693, 122.16, 1.6954, 111.7568, 276.6101, which are as entered in column 6. Now, the sum of f into x minus mod square is 18157.32. Now, we shall consider an arbitrary value a is equal to 19.5. As a first step, compute the deviation of the observations from an arbitrary value, and the values are minus 13.5, minus 9.5, minus 5.5, minus 1.5, 2.5, 6.5, 10.5, 14.5, 18.5, which are entered in fourth column. Now, square these observations. The values are 182.25, 90.25, 30.25, 2.25, 6.25, 42.25, 110.25, 210.25, 342.25, which are entered in the column 5. Then, multiply the values of column 5 with the frequency values in column 3. The values are 2004.75, 1173.25, 484, 31.5, 62.5, 380.25, 1874.25, 1261.5, 1369, which are as entered in the column 6. Now, the sum of f into x minus arbitrary value square is 8641. Comparing all the four values, we observe that summation f into x minus x bar whole square is equal to 8623.36 is minimum. Hence, we can say that the sum of the squares of deviation of a set of values is minimum when it is taken from mean. 100 students appeared for an examination. The results of who failed are given below. Marks 5, 10, 15, 20, 25, 30. Number of students 4, 6, 8, 7, 3, 2, which is the total is 30. If the average marks of all students were 68.6, find out average marks of those who passed. Given the number of students n is equal to 100. Let n1 is equal to number of students who failed in the examination, which is equal to 30. Let n2 is equal to number of students who passed in the examination, which is 100 minus 30 is equal to 70. The average marks of all the students is x bar is equal to 68.6. Let us compute the average marks of the students who failed in the examination. Accordingly, compute f into x values. The values are 20, 60, 120, 140, 75, 60. The formula used to compute mean is x1 bar is equal to summation fx1 divided by n, which is equal to 475 divided by 30, which is equal to 15.83. Hence, the average marks obtained by the students who failed in the examination is 15.83. Now, let us use the combined mean formula in order to determine the average marks of the students who passed the examination. That is, x bar c is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2, which implies 68.6 is equal to 30 into 15.83 plus 70 x bar 2 divided by 30 plus 70, which implies 68.6 is equal to 30 into 15.83 plus 70 x bar 2 divided by 100, which implies 6860 is equal to 475 plus 70 x bar 2, which implies 6860 minus 475 is equal to 70 x bar 2, which implies 6385 is equal to 70 x bar 2. Therefore, x bar 2 is equal to 6385 divided by 70, which is equal to 91.214. Hence, the average marks of the students who passed the examination is 91.214. Summarization. In this module, we have discussed some practical problems that we have covered in this entire course. Thank you.